Howdy folks, Mr. Hess back here with another geometry lesson. Today's lesson is 4.1, so it's the first lesson of Module 4, and it's titled Slope and Equations of Parallel Lines. Okay, so today our lesson is going to be about slope. That'll be the main focus of today. Now, many of you, I'm sure, are already familiar with slope. I'm sure you've worked with that back in your algebra days when you were working with linear equations and had to graph them on a graph. So first of all, let's just do some quick review. There is a certain letter that is used to represent slope. You would think it would be the letter S, but they don't pick the letter S. Oftentimes that letter is avoided because the letter S, you can see, looks like the number 5. Okay, but in its place then, they've used the letter M for slope. I think I looked it up once, and some people speculate that there is, I think there was like a French name for slope that started with M, so they chose M, even though it's not a letter in the name slope. Okay, but M is the traditional letter used to represent slope. And usually when I ask people about slope, you know, what is it? They're able to spit out a concept of slope, you might say, where it's blank over blank. You know, there's a certain value put on the top of a fraction here, and then a certain value on the bottom. And those values are determined by the slope of the line. So we say that it is the rise over the run. Rise over run. Most people, again, can tell me these two things about slope, that M is the letter used to represent it, and rise over run is how we find it. When you think about that, rise over run, rise is referring to a movement up or down, right? You know, rise up or fall down. Okay, but movements up and down then are determined on an XY coordinate plane by our Y values. Y values run up and down. Okay, and the run refers to then a side-to-side motion. Okay, so whether it went forward or backwards. Okay, run refers to movements from side to side. And side-to-side movements, as you can see, are all X values on our XY coordinate plane. So Y values will determine the top, X values will determine the bottom. And there is an equation, there is a formula that we can follow given any 2 points on a line. For example, let's say I had these points. -2, 1, right there, and 3, 8. 3, 8. Okay, 1 point there, 1 point there. If I were to join these with a nice straight line, I'm going to try to freehand this. That's not bad. I'll make sure those points are extra big so you can see those. Okay, so there was my coordinates, -2, 1. And here's my 3, 8. Okay, but the formula for figuring out this slope is to calculate that rise over run. So on top, remember we just said rise are values that run up and down. They're Y values. So on top, you're going to be subtracting your Y values. So the formula says to take your Y2 and your Y1, your 2 Y values, and subtract them. Okay, and then on the bottom, the run, remember that's movement side to side. That's determined by X values. So on the bottom, to figure out your run, again, we are going to subtract, but this time you'll be subtracting your X values. Now, it really doesn't matter which one of these points you call your x1, y1, your first point, or your x2, y2, your second point. However, I will say that unlike the distance formula, where the distance formula you could get them reversed and it didn't matter, on this, you do have to be consistent in the order you put them, in the pattern. So you see how I went 2 minus 1 and 2 minus 1 on this one? You're allowed to switch them, but you'd have to switch them both. So then you'd have to go 1 minus 2 and 1 minus 2 if you wanted to switch them. You can't go 2 minus 1 up here and then down here go 1 minus 2. Okay, you got to be consistent in the order that you subtract them. So stay with the same pattern. Okay, so let's do that on this one over here. Let's figure out its slope. So on top I would subtract the y values. Now be careful. The most common mistake when people figure out slope is they want to put the x values on top. They think, oh, alphabetical order, x before y, so x values should be on top. No, not with slope. With slope, it's rise over run, so your y values have to be on top. Okay, so I see I have y values of 1 and 8. Now again, I don't care which order you subtract them in, but whatever you establish as your pattern for the first two, you have to stick with that pattern for the next two. So if I want to go, for example, 8 minus the 1, if I want to go over here, clear over to the right, and then subtract the 1 on the left. So right minus left, 8 minus 1 would be the top. Now if I want to continue that pattern of going left minus right, then I'd have to go 3 minus negative 2 on the bottom. Be careful with the negatives. Okay, that created a double negative, in fact. But you see what I'm doing? I'm going right to left, right to left. So 8 minus 1, 3 minus negative 2. All right, so let's do the math now. 8 minus 1, as you can see, is 7. 3 minus negative 2, that's a double negative, which becomes plus positive. 3 plus 2 is 5. So the slope of this line over here would be a positive 7 over 5. Okay, and what that really is saying, if you look at it as rise over run, is that if you start down here, and if you were to rise up 7 and run forward 5, that's how you end up over here. So if you were to go up 1, 2, 3, 4, 5, 6, 7, it rised up 7, and then run 5. So 1, 2, 3, 4, 5. See it? Up 7 over 5. That's what it's telling us happened. Okay, every time when you make lines, if your line runs uphill, see how if I'm going left to right, just like when I read a passage in a book, when I go left to right, see how this is going uphill? All uphill slopes are always positive, just like this one was. This was a positive 7 halves, or sorry, not halves, 7 fifths. Okay, but you can, here, I'll put it down here as a little note to ourselves that if the line runs uphill means that it will have a positive slope. So all uphill lines should have a positive slope like that. For poops and giggles here, let me just show you too that even if you had subtracted these in the opposite order, it still would have came out the same, as long as you are consistent in the pattern that you do it in. So initially when I did 8 minus 1, do you see I was going right minus left? 8 minus 1, 3 minus negative 2. So let's flip it around. Let's put the 1 first and then the 8. So instead of 8 minus 1, let's do 1 minus 8. So if I do that pattern where I'm going left to right, I got to do it again with the x values and go left to right. So it'd be negative 2 minus 3 on bottom. Now I want to show you we're going to get the same result. But here's the difference. On this one, 1 minus 8 gives me negative 7. And down here, Negative 2 minus 3 gives me a negative 5. However, you should have learned in your previous algebra classes and stuff, in your previous math classes, that a negative divided by a negative is really just a positive. So a double negative here, negative divided by negative, is really just positive. So this is really just positive 7/2. Okay? If they're both negative, then it's really positive. If they're both positive, it's positive. If any one of them was negative, then it'd be negative as a whole. Okay? But since they were both negative, they cancel each other out, they become positive. Alright, so that's an uphill line. So now let's take a look at some other types of lines besides uphill. That does not want to erase very well, does it? Alright, so I've got a new problem I put up here. As you can see, this line, instead of going uphill, as you go left to right, this one's going downhill. Okay, so I want to see what effect that has on our slope. It goes through these points at -4, 5, and down here at 2, -3. So let's plug them in. Let's see what we get for our slope. So we have y values on top again. So try to get in that habit of putting your y values on top for slope. So I've got a 5 and a -3. If I just go, left to right like it's red normally, we could just then do 5 minus the -3. Now if I'm going left to right with the y values, 5 minus -3, I got to do the same with the x values. So -4 would be my first one down here at the bottom, and I would subtract from it the 2. Alright, now we do the math here. We have to simplify all this. We got a double negative, that becomes plus positive. 5 plus 3 is 8. -4 minus 2 is -6. Okay, now here's that scenario I was discussing a minute ago. If only one of the two numbers we're dividing here is negative, then that means the fraction as a whole is negative. Because a positive divided by a negative would be negative. And then this actually reduces a little bit too. Since slope is fractions, all the usual fraction rules apply. So if you can reduce, you really should do so. And 8/6 does reduce. I know, for example, 2 goes into both of them. 2 goes into 8 4 times. 2 goes into 6 3 times. So this 8/-6 reduces to a fraction of -4/3. So there's our slope on this one. And again, it doesn't matter what order I subtracted these in. If you want to switch them both, you'll get the same result. If you want to go -3 minus 5, which would be a -8 instead of +8. And if you want to go 2 minus -4, which would be a +6 instead of a -6, all it really does is it keeps the 8 and 6, it just switches the signs. It puts the negative up here and the positive down here, but a positive divided by a negative or a negative divided by a positive is still just negative. Okay, and I think you're going to find that this is true about all downhill lines. All downhill lines are going to have a negative slope, like we had here. Uphills are positive, downhills are negative. Let's put that right here. Downhill equals negative slope. Now, there are some other possibilities to consider because not all lines run uphill or downhill. We could have a line do the following. Okay, here's my new line. If you look at it carefully, it's a perfectly horizontal line going through the coordinates 2, 7, and 8, 7. Okay, so let's put that into our slope formula and let's see what happens to the slope of this if it's perfectly horizontal like that. Okay, so according to our slope formula, we got to subtract our y values on top. My y values are matching 7s. Really doesn't matter what order I subtract those in. 7 minus 7 or 7 minus 7 is still going to be the same. So I don't care if you call this going left to right or right to left. Either way, you want to call it. Down here, of course, then you would have to try to continue that pattern. So if I said, for example, that my 7s up here are going left to right, 7 minus 7, then I would continue that pattern and go 2 minus 8 on the bottom. Well, 7 minus 7 is 0. On bottom, 2 minus 8 is negative 6. Now, if you were to put this into your calculator and see what you get, or you don't really even need a calculator if you got, the world's best calculator in the world right here. But if you take 0 and divide it by any number, any number besides 0 itself. So if you divide 0 by negative 6, if you divide 0 by positive 6, it doesn't matter. You always get the same result. You get 0. Okay, so a perfectly horizontal line like this is always going to have a slope of 0. Don't say that it doesn't have a slope. It does. It has a slope. It's just 0. Okay, so if you think of all these slopes kind of like skiing slopes, we had our uphill slopes. So, that'd be like going uphill up a ski slope. If you go down a ski slope, there's downhill. So remember, uphill was positive slopes, downhill was negative. Well, this up here would be when you have no hill at all. You're not going up or downhill. It's flat ground. Okay, it's what we would call cross-country skiing. You ever see that on TV where they're using their poles and they're just kind of pulling themselves along nice flat ground. Okay, so think of it like that. So then that might help you remember then its slope, since it's perfectly flat, it has a slope of 0. It's not tilting up or down. Now there is a last scenario here yet. One more type of line to consider, and it's the complete opposite of the horizontal line. Here's that complete opposite. That would be the vertical line, is the complete opposite of a horizontal line. Okay, and let's see what happens with our slope when we use our formula for slope here to calculate this slope. On the top, we do the y values. So I've got 6 and negative 1. Again, pick an order and stick with it. So if you want to go top minus bottom, then go top minus bottom on both. But if you want to go bottom minus top, then go bottom minus top on the second one as well. I'm just going to go top minus bottom. I'm going to go 6 minus negative 1. So there's my y values subtracted, and now I got to continue the same pattern, going top minus bottom, top minus bottom. So negative 3 minus negative 3. Now, kind of like the horizontal line, I think you're going to find that you end up with a 0 involved here, because negative 3, and then this is double negative, so plus positive. So negative 3 plus 3 is 0. On top, though, here, the double negative becomes plus positive, and we get 7. So on the previous one where we had the horizontal line, the 0 was on top, and then we had some number on bottom. Now I've got the number on top and the 0 on the bottom. Okay, when you punch that into a calculator, though, the calculator is going to tell you error. It's going to say error, you can't divide by 0. That's a big no-no of mathematics. You can't take, like if this was 7 pizzas, you can't divide 7 pizzas into 0 parts. The pizzas have to go somewhere. They can't just disappear. So this is an impossible math problem. You can't divide something into 0 parts. Now, because that's an impossible math problem, then there's no number I could write that expresses this slope. And since there's no number I could write for the slope, then we just simply say that this slope is, you may remember this from algebra, undefined. Undefined. So any vertical line like this then has an undefined slope. And it even fits into our analogy that I was talking about earlier about snow skiing. You know how we had uphill was positive, downhill was negative. The horizontal line was cross-country skiing because it was flat ground. Well, if you're skiing and all of a sudden you come across this would be like a cliff, right? If you're skiing along and all of a sudden you come across a straight down path, that's a cliff. And if you're snow skiing, you can't ski a cliff. Okay, you can't ski that. Unless you got a parachute or something, you know, you're going to die if you go down that cliff. Okay, so it's undefined. You can't do it. You can't ski that. So that's a good way of thinking of that. So I want to add to my list down here those two that we just mentioned. Don't forget that the vertical lines, like I'm just doing here, vertical lines are undefined in their slope, but the horizontal lines that ran that way, remember, had a slope of 0. Again, that doesn't mean it doesn't have slope. Same with this one even. You know, you don't argue that this doesn't have slope. It has slope. It's just that its slope is so. Its slope is actually this. It's so steep. You know, as the uphill part I was talking about earlier. If you keep going more and more uphill, this number for the slope of this keeps getting to be a higher and higher number. You know, you might start out with a gradual slope of only like 1/4, 1/4, and then it might get bigger and bigger and become, you know, like 2/4 or 1/2, and get bigger and bigger, and eventually that number here gets so big, the slope gets so high, the number's so high that it goes off the charts. You know, it goes off into infinity, so it can't be expressed. It's undefined. All right, so that covers our 4 types of lines. There's uphill, downhill, vertical, and horizontal. Next, I want to take a look at parallel lines, because this section, this lesson, does involve parallel lines. All right, now pictured up here, you can see I have drawn a couple of lines that are parallel. Okay, they're running in the same direction. We know that parallel lines would never intersect. Okay, and when it comes to their slopes, there is something true about their slopes when you have parallel lines. So let's take a look at them. As you can see on this line right here, if I look at its rise over run, I see that it rises up to this point right here, and then it goes to the right over here in this direction. So it rises up 1, 2, 3 units up, and then 1, 2, 3, 4, 5 units this way. So you could say that this line right here has a slope then of 3/5. Rise over run, y values over x values, so 3/5. If you look at this line that runs parallel with it, if I look at this point and what it takes to get to here, again, I can see it goes up a certain value and over a certain value. And if you count, it goes 1, 2, 3 units up again. And 1, 2, 3, 4, 5 units over again. So just like our last example, this also has the exact same slope. Okay, so the point being then that when we talk about parallel lines, I want you to realize that parallel lines are always going to have the same slope. Okay? So keep that in mind. Parallel lines have the same slope. Now, if we're talking about segments instead of lines, instead of a full line, I also want you to realize that being parallel has nothing to do with the lengths of the segments. So if I had shortened this up, where this ended right there at that point and began right here, let's say, at that point, you see how that segment still has that up 3/5 slope. So the slope didn't change any. But then this segment, maybe it keeps going for a while, Maybe it went, let's see, down another 3 and back another 5. 1, 2, 3, 4, 5. Maybe it went clear out to here yet. And, then maybe it ended, let's just say, right there at that point. Okay, so if you look at my two segments I've created now, both of them still have the same slope. They're still going up 3/5, up 3/5. Even right here, you could say I went up 3/5 again. Okay, so it still has the same slopes, so they're still parallel, but it just helps me emphasize the point that parallel has nothing to do with length. So if you look at their lengths, this one's twice as long as this one is. Okay, but they're still parallel. Okay, now the next thing I want to do is really review of what you should have already learned in algebra. And this may look familiar right here. Y equals mx plus b. Better known as, do you know? It's better known as slope-intercept form. Slope-intercept form. Okay, but so I want to do a quick review of that. That does kind of come into play on some of the problems that we're going to do here in this module. So a quick review of this then. First of all, to be in slope-intercept form, you have to have the y by itself on the one side. See how it starts out with y equals. Okay, so that y has to be by itself on the one side in order to be in slope-intercept form. When you do have the y by itself, then on this side of the equation, it points out two things, thus the name slope-intercept. It points out that this m will actually be replaced with an actual number, though. But this m that's in front of the x, that, of course, since it's the letter m, is representing our slope. And then the end value here, the plus b off the end of here, that value, and I kind of circle the plus part with it because sometimes that might be a minus sign, though. So it might be a positive number or a negative. But regardless, that number right there on the end, that constant value that's not in front of the x, is then the y-intercept. Thus the name slope-intercept form, because this is your slope and this is your y-intercept. Okay, let's try it out. Let's do a problem then and show you how this would work. And when you have it in slope-intercept form eventually, it does make it easier to graph as well. Okay, so let's say we start with this equation. 3x minus 12y equals 24. Now, currently as it's written, I can tell right away it is not in slope-intercept form because from the get-go, remember I said that to be in slope-intercept form, the y has to be by itself on the one side. So it has to be solved for y. This is not solved for y. See how there's a 12 in front of the y, and then there's even a 3x over here with it. Okay, so we're going to have to do some work here to get this into slope-intercept form. We're going to have to do some algebra, basically. So I want to solve for the y. So act like this x over here is not an x, but an actual number. You know, treat it like you normally would if this was just like a 3 instead of a 3x. So if I wanted to get this y by itself, you know, your focus should be on the y. Then I need to get rid of all of this over here, the 12 and the 3x. And in algebra, like we've talked about before, you always want to do your adding and subtracting first, save division for last. Okay, so do you see any of these that I can get rid of by adding or subtracting? Well, yeah, I could get rid of this 3x that you could say is a positive 3x that's currently being, you might say, added. We can subtract it. Whatever we do to one side, we do the other. Now be careful when you do this though. Over here, these cancel. That was the whole point. That leaves us with a negative 12y. But on this side, you can't actually take x's away from non-x's. Those are not like terms. So we can't actually combine those in any way. So all you have to do is leave them separate from each other. So just leave that as 24 minus 3x. If that drives you nuts that the x is written last instead of first, you're welcome to switch that around. If you do switch it around though, make sure this negative goes with the 3x. Okay, because that is already tagged onto there. That's a negative 3x. So if you do want to put that first, write the negative 3x first, and then put the positive 24 or plus 24 on the other side. If this didn't bother you up here, though, you can leave it this way, too. I'm just switching it so my x value is written first. Some people like that. So that it's, you know, like this up here, where the x is written first over here. Okay, now that's still not in slope-intercept form because the y is not yet by itself. I still need to get rid of this negative 12 that is currently being multiplied. So to get rid of it, of course, I have to do the opposite. I have to divide. And whatever you do to one side, you have to do to the other. So do you see how I divided that whole side by negative 12 over there? Now on this side, of course, everything cancels except for the y. So that now I'll have it in slope-intercept form when I'm done here. Now over on this side, though, I got to go ahead and do the division. And I'm dividing this whole side by negative 12, which means I have to divide this part by the negative 12. And I got to take this negative 12 and divide it into the 24 as well. Okay, it's kind of like the distributive property. Remember the distributive property, if you multiplied this whole side by something, you had to distribute that number and multiply it times both. Okay, we're doing the same thing, only instead of multiplying, we're dividing. So we're dividing this into both. Okay, now the nice part is when I draw that with those, when I circle that and go, okay, I'm going to divide this, I'm going to divide this. Look, it makes a heart shape. Oh. So just in time for Valentine's Day, which is coming up before you know it. All right, so let's do our divisions. Again, one by one. Each one is a separate division. So over here, a negative divided by a negative would be a positive. 3 divided by 12 does not come out to a nice whole number, but it does reduce. Do you see that 3 over 12, 3 divided by 12, would reduce to 1 over 4. 3 goes into 12 4 times. So this is just going to be a positive 1/4. And don't forget the x. The x is still there. In fact, whatever's in front of that x is going to be our slope. See? So that comes into play here. All right, now for the second half of this, now I'm doing another division problem, only this time it's positive 24 divided by a negative 12. So positive divided by a negative is a negative. And then 12 does go into 24 nice and neatly. it goes into there 2 times. So I get a -2 for that spot. Now this equation is in slope-intercept form. The y is by itself. And now I could look at this and be able to graph it by determining what my y-intercept and slope are. Okay, when you get it, the y by itself in slope-intercept form, I like to always look for the y-intercept first, because that y-intercept is where it's going to cross the y-axis. Thus the name y-intercept. It crosses the y-axis. So if you look, earlier I circled this whole thing indicating that you need to pay attention to this sign as well. So you see that -2 on the end there, just like up here, that's going to be my y-intercept. So I know that this line would cross the y-axis down here at -2 on the y-axis. -2. And then the value in front of the x is our slope. So in front of the x, do you see, was this part, the positive 1/4? So there's my slope. That's telling me to go up 1 and forward 4. So I go up 1 and 1, 2, 3, forward 4. You can do that as many times as you need to. Up 1, forward 4, till you can make yourself a nice straight line. You could even, instead of going up 1 and forward 4, you could actually even go down 1 and back 4. If you do everything completely opposite, it's the same slope still, see? See how that still runs in the same line there. Okay, it'd be as if I had put negatives on both the top and bottom. When I'm going down and back, see, it'd be down 1, back 4. But a negative over a negative is equal to a positive. So these are the same slope. Okay? So that's slope-intercept form. Again, rehashed for you. A little bit of review for you there. Okay, now I want to start showing you some problems that you're going to find on your homework as well. So I'm going to give you a sample of each so you have an idea on how to do these. And one of the types of problems that you're going to run into on your homework will ask you to write the equation of a line that is parallel to this line and passes through this point, 10, 2. Okay? So one of the first things I want to do is, if I'm going to have my line be parallel to this, then I know that parallel lines, like we've mentioned before, have to run in the same direction and have the same slope, right? To be parallel, we learned today, they're going to have the same slope. So what I need to do is determine the slope of this line. Now, the way it's written right now, it's not easy to determine its slope, but if it was in slope-intercept form, which remember again was this, y equals mx plus b, where the y is by itself. So if I could get it in that form, then I could quickly identify the slope. It'll be the value in front of the x. So right now, don't do it yet, because your slope is not -3. I know that's in front of the x, but that's not it. We first have to get the y by itself. So I see on this one that I've got a 5 in front of the y, and of course this 3x, this -3x over here with the y. So if I want to get this y by itself, I need to get rid of all that stuff. Now again, in algebra, there's a certain order you go in. Remember, you want to add and subtract first. So I can get rid of this -3x by adding a 3x. So I'm going to do the opposite. And whatever I do to one side, I have to do the other. This will cancel, leaving me with 5y. And over here, again, just like I showed you earlier, this is an x term that is not. So these are not like terms. You can't just add this 3 to the 15 and call it 18. They have to stay separated, stay separate, because they are not like terms. So you just leave it as 15 plus 3x. Or, like I mentioned earlier, if that really gets on your nerves that the x is not written first, feel free to switch these around. You know, you can move this positive 3x to the front, and you can move the positive 15 to the end. That's still the same thing if you switch it around like that. Okay, now I want to get rid of the 5 that's in front of the y so that I'll finally have my y by itself. So if I divide by 5, that would get rid of it, right? Because it's currently being multiplied, and I want to get rid of it, so I divide. Whatever I do to one side, I have to do to the other. Okay, and then over here, that means I've got to take that 5 and divide it into here and into there. Remember, I told you it makes that heart shape. So let's start with the value that was in front of the x. This will be our x term. We have 3 divided by 5. Does that come out nice and neat? No, there is no nice whole number for that. Leave it as a fraction, though. Just leave it as 3/5 x. After all, whatever's in front of the x is going to be our slope. So it's okay that it's in a fraction form. In fact, it's kind of preferred. After all, you know, a slope is supposed to be rise over run. So this would rise 3 and run 5. The second part of this, the 15 divided by 5, would give us 3. Although I will say this 3 plays no part in this problem right now because all I wanted to do was make sure that I was parallel to this line. And this line has a slope of 3/5. So that means my line will, the line that I make this parallel, will also have a slope of 3/5. In fact, if you look at the information I have now I could take this 3/5 and I can actually plug that in here. So I can put a 3/5 in for m. And then I can do a little bit of more substituting here yet. Here's the point I wanted it to pass through. And on my coordinates, this is my x coordinate, this is my y coordinate, right? So I could say my x value of the equation that I'm going to make will pass through x at 10. So I'm going to put a 10 in for the x here. And I'm going to plug in for the y, the 2. So the problem now looks like this. If I plug it all into that slope-intercept form, I plug a 2 in for the y, I put a 3/5 in here for the slope, I put a 10 in for the x, and these are being multiplied. Or here I'll put it like this with parentheses. And then the b is the only thing I don't know, see? So by plugging all these in here, now I'll be able to solve for the b, and that'll be the last part that I need for my equation. Because I'm supposed to write an equation, you see here, of the parallel line. Alright, so let's do some math here. This 10, since I want to multiply it by this fraction, 3/5, it would be easier if this 10 was also a fraction. So I'm going to call that 10 over 1. That's a fraction that would equal 10, right? And by putting it in this form now, it makes it easier to multiply this, because I hope you see that we could do some canceling. See how this 5 would go into this 10 2 times, and 5 would go into itself once. And now when I do my multiplying, it's a lot easier, because now I have 3 times 2 is 6, and on bottom I have 1 times 1 is 1. So 6 over 1. That's just 6. You know, this 3/5 times 10 just came out to 6. Bring that down, bring this down. Now it's some very simple math here. If I subtract the 6 from both sides, now I'll have my b. And you can see that in this case our b comes out to -4. So my final answer, my final equation, I'm going to write over here now. I can plug back into slope-intercept form, but this time This time, don't put in the 2 for the y. Don't put the 10 in for the x. Leave those as just y and just x. And just simply plug in our slope, which we used the slope of 3/5. It came from here, remember? So put that slope in front of the x. And I just found my b, my y-intercept here, to be -4. So I put a -4 on the end, and there's the equation. That would be our solution on this one. Okay, so again, they wanted us to come up with an equation parallel to this, passing through that. So I took this, I solved for y, so I know my slope. If it was already solved for y for you, that would be a lot easier. You don't have to do all this work then. You would just be able to steal this 3/5 for your slope. You plug that into here. You plug in your x and y values from this point that you want it to go through as well. After plugging all that in, you solve that for b. And then that b goes into our equation at the end over here, along with that slope of 3/5 here. So that's how I got that equation. Okay, I'm going to give you another problem to try. Okay, you can see up here is our new problem. This time they want us to find the equation of a line that passes through this point and is parallel to a line that passes through these 2 points. So it's just like the last problem we did, essentially, only the only difference is on the last problem we did, instead of saying, oh, it passes through these 2 points, they actually gave you the equation. Okay? Remember on that last one, they gave you the equation that was like 3x minus, what was it, like 12y equals 24, something like that. Remember, they gave you that equation. Okay, instead of giving you this equation, though, this time, they're just going to say, oh, we want it to be parallel to a line that passes through these 2 points. Now, even when they gave us this equation, all we did was solve it for y so that we could find the slope. And that's all we really needed, because if it's going to be parallel lines have to have the same slope. So I don't have to worry about working with some big equation like this on this problem. On this one instead, what I could do is simply take the 2 points that this one passes through. So this line that passes through these 2 points, let's find its slope. Remember that slope is y2 minus y1 over x2 minus x1. So if we plug in these values down here, these two, for our formula here, let's see what we get. So y values, remember, go on top. So I'm going to take this 8, I'm going to subtract it from the -1. Since I'm just going left to right, I'm going to continue the pattern on the bottom and go left to right again. So 4 minus 2. All right, double negative plus positive. So 8 plus 1 is 9. 4 minus 2 is 2. So the slope of the line that is passing through these 2 points, the slope of it is 9 over 2. So that's going to be the same slope I'm going to use for my parallel line. Okay, so that tells me quite a bit right there. That's my slope. And now we just do the same work we did earlier. Remember, we take this y equals mx plus b, and we're going to start to plug in for the x, the y, and the m. We're going to plug in for everything but the b. Okay, so this 9/2 is going to go in for the m. And then the x and y values, remember, come from this part up here. This is the point we wanted it to pass through. So we know if it passes through this point that these are solutions to it, where your x value, when your x value is -4, so your x is -4. And your y is 5. Don't forget that plus b on the end. Okay, I'm going to call this -4 over 1, like we did earlier, to make the multiplication easier here. And again, there's some canceling we can do. I see that 2 goes into 4. 2 goes into 2 once, and 2 goes into a -4 2 times. And so now on bottom, I just have 1 times 1. So I know this is going to be a whole number. And on top, I have 9 times -2, which is -18. Okay, bring the rest down. You know, the 5 over here, the b over here. I want to get this b by itself so I can figure out what my y-intercept's going to be. So I would add an 18 to get rid of that 18. And whatever you do to one side, you got to do the other. So this one's gone. And over here I have 23. So there's my b. b is 23. So now that I have the m, the slope, and the b, now I should be able to fill in the final answer, the equation. So I go back to my y equals mx plus b, but this time I do not plug in for the x or the y. I'm going to leave those as x and y in the equation. But I do plug in my m, 9 over 2. And I know my b is 23. So this would be a positive 23 on the end. So there's my equation for that one. It would be the equation y equals 9/2 x plus 23. Okay, so again, just like the previous problem, only instead of giving you an equation that it has to be parallel to, they give you a line that would pass through these 2 points that it needs to be parallel to. So you got to calculate your own slope and then plug in. Okay? I still have a few more problems to show you. Alright, now one of the things that I forgot to mention when we were covering slope-intercept form is some special case scenarios. Every now and then you'll see equations that rather than having both the x and the y in them, sometimes they just have one or the other. Like you might have an equation that says x equals 5, or another equation that might say y equals -3. Okay, these are special cases. In fact, they're illustrations of these 2 special cases, vertical and horizontal lines. Okay, just to show you what I mean, in this equation right here, x equals 5, if I was to do an old-fashioned XY table, remember back like in 3rd or 4th grade or something when you did this, and they would have you pick some x values, you plug them in, and you find some y's, and you'd graph it and see what the graph looked like. Well, when you look at this equation, the only thing they're specifying here is that x is 5. So you see your x column right here, you could actually fill this with nothing but a bunch of 5s. Then you notice how in this equation, though, that they don't say anything about y. So since they don't say what y can be anything. You know, pick any y values you like. You could pick a 0. You could pick -2. You could pick a +4. You know, any y values you want. But now if you plot these points, you know, look at these as coordinates, your x and y coordinate. So the first point would be 5, 0. So if you plot that point, 5, 0 would be right there. 5, -2 is my next point. Well, 5, -2 is right there. 5, 4 is my next point. 5, 4 would be right there. Okay, do you see that if I kept making more and more points, if I kept putting more and more 5s here and more different y values here, it would just keep making more and more points that run like this, right? That run perfectly vertical. Okay, so anything of this nature where the formula looks like this, where x equals, and then fill in the blank here with any number you want, it doesn't have to be 5, but if it's just that, an equation of that form, where it says x equals and then a number, those are always going to be vertical lines, and like in this case, if the x is 5, it would go right through 5 on the x-axis, in fact, because all those points have a x value of 5. So along that same note, you know, this one, of course, as we could say, is vertical. Then this one down here, I think you're going to find is the horizontal one, where y equals -3. Instead of an x here in the front, it's got a y. Again, we can make a little table to kind of illustrate this. And again, when you look at your equation, y this time, not x, but y has been restricted to -3. So all of my y values over here are now going to be all the same, -3, just like I made all of these be 5s for x. But my y stays the same, it's -3. My x, on the other hand, since they didn't specify here what x was, x can be anything. So this is where you get to pick any values you want here. Again, you could pick, like I did up here, like a 0 and maybe a -3 and maybe a +7, you know, something like that. You know, plot these points, and I think you're going to find as we graph these that we're going to get a nice horizontal line this time. So 0, -3 would be right there. -3, -3, -3, -3 is right there. And 7, -3. 7, -3 is right there. So you can see my points coming together. They're starting to make a line that, like as I just suspected, is perfectly horizontal on that one. So all horizontal lines will have the format y equals, and then you get to fill in the blank here with whatever number you want there. In this case, it was -3, which means it's going to be a horizontal line going through -3 on the y-axis. Y is -3. Okay, so now that you see those special cases for the vertical and the horizontal lines, this last type of problem that I want to show you then pertains to that. So let me flip this around, because on the other side here, I have the problem. And it says on here, we're going to identify the slope of the line x equals -2. Write the equation of a line parallel to x equals -2 and passing through this point. So it's like our previous problems where we're going to eventually make a line be parallel to the given line here, passing through that point. Okay, but the first thing they actually wanted you to do is identify the slope. So any line, remember, any line with the format x equals blank, like we have here, x equals -2. Okay, do you remember what kind of line it was? Again, remember, it's essentially saying that the x values are restricted to -2. The y values can be anything, you know, like 0, 1, you know, -5, whatever. If you plot these points, I think you're going to find that they are going to line up to make a perfectly, yes. Here, I'll do a quick sketch. -2, 0 would be like down in here. -2, 1 would be right there. -2, -5. Oops. What am I doing? It's start over on that. Negative 2, 0 would be over here. Negative 2, 1 would be up here. Negative 2, 5, negative 2, negative 5 would be down here. So you can see it's going to make a nice perfectly vertical line. And what's the slope of any vertical line? Remember, if you think of it in terms of skiing, that's like a cliff. You can't ski a cliff. So our first answer for the slope is that it's undefined. So there's my M, my slope. All right, now the second part, creating a line that's going to be parallel to this, but passing through that. Now, believe it or not, this is really easy. It's a lot easier than the previous problems we were doing. Because anything parallel to a vertical line is going to be another vertical line, right? You know, this would be parallel to that. This would be parallel. This would be parallel. This would be parallel. You know, it'd have to be another vertical line. So again, it should have this format here of x equals. But I need it to pass through this point. So if it's going to be x equals some number here, we just got to figure out what number to put. Well, if I want it to pass through this point, do you see on this point, there's my x and there's my y value. So I want it to have the same x value as this one, right? I want it to say x equals, and it has to have a 7 for an x. So there's my answer. It has an undefined slope. The parallel line would have the equation x equals 7. You don't need the negative 5. That's the y value. Remember, the y values can be anything. 0, 1, negative 5, you know. So it's just the x value you steal from this point and put it in a new equation. Instead of x equals negative 2, we have x equals 7. But they're guaranteed to be parallel. Now, of course, this whole problem would change a little bit if I were to make some changes on the equation. Instead of x equals negative 2, what if I changed it to y equals negative 2? Okay, it'll create some changes down here as well. Remember that instead of having an equation of the format x equals, now this is a y equals. So instead of being a vertical line, remember that ones that are y equals are going to be horizontal lines. So it's not an undefined slope anymore. If it's going to be horizontal lines that we're making, those all have a slope of 0. And down here, instead of the equation x equals 7, our answer is going to be, if I want a parallel line to it, another y equals equation. But it's got to pass through this point yet. So instead of, like on our previous problem here, when we stole the 7, the x value for here, now I want to steal the y value. So the y value here is negative 5. So I would say that if the line was changed to y equals negative 2, that its slope is now 0, and the parallel line is y equals negative 5. We steal that y value. All right, there you have it. That's how you do those problems, and that should be enough to prepare you for your homework.